Hello everyone, Altar of Wisdom speaking. Today we're continuing our journey towards building a kick device in Maxforlive, and we'll be specifically working on switching from message-driven signals to audio-rate signals to try to solve this phase retrigger issue that we have been looking to in the previous session, and let's get on to it. Okay, so we clearly have an issue with the phase here. If I just press play here, we clearly see that the phase relationship between the successive shots is moving. So definitely using the phase inlet wrongly in my cycle. So it doesn't seem to work. And looking at the documentation, actually when using the phase inlet, I should be providing myself the phase, not a start value of phase, but actually the phase. So I would need to provide a cycle from 0 to 1 about the phase which I'm requesting to the device. So we need to figure out a way to reset the phase and make sure that it's happening properly. So thinking about a way of doing so. So what I actually can do here is switching to a different approach. It's a bit more cumbersome, but I don't find another way. Instead of driving a cycle here, I'm gonna drive the phasor, which is one of the most important objects in Maxforlive. A phasor is actually an object which basically covers from 0 to 1 in a given amount of time without any anti-aliasing. It's a saw wave, so up. If I just put a frequency on it, so it's really a saw wave, but it has absolutely no anti-aliasing. If I instead use a saw, which exists as well, in this case, let's put the same frequency. You see that it's not popping because it's really meant not to provide clicks. So a saw is really meant to be used as an audio source, whereas the phasor is really a signal driver and not a source, anyhow. So if I just connect that to the audio out, you're gonna hear that it's. We can give it a try. Let's say a phasor at 2220, connecting it here. So it's okay-ish, but still it's less clean than what you have if you're using the saw instead. So let's put the same frequency but on a saw. Yeah, it's pretty hard to tell the difference, but yeah, I can assure you that we really on this phasor we really have an instant switch from 1 to 0, and this is definitely the type of stuff that you want to avoid if you want to drive an audio to make an audio signal, because it will cause clicks and pops. It's like in LFO tool when you have this the end amplitude going from 1 to 0, and you definitely get a click in that point. So anyway, here we're not willing to use phasor as a signal, as a sound source. We want to use phasor to actually control the frequency, the actual phase of my sine wave. So my phasor would be connected here and would be driving the frequency, the phase of my sine wave. So I need we'll see that it's not enough, but I need to, instead of connecting my frequency to the cycle, I'm going to connect it to the phasor. And you see that even though I am not providing a frequency here, it's still doing things. If I send a message, you see that the frequency of my sine wave is changing because its frequency, its phase is following the phasor. Let's see if I can bring it a bit more visible. So this is my phasor, and you see that my phasor is changing its frequency, and in turn is sending accelerated phases to my sine wave. However, I need to start this each time, to have a fixed phase each time I get a message. And to do so, we have that something that any Psytrance guy will like, of course, because it's called the sample and hold object, because it's really what it does. It's gonna sample a signal and hold it until we get a trigger to take it again. So how do we ensure that we are starting at 0? Of course, I've already thought about that, and it's one of the typical tricks that you can use to restart. So my phasor will be connected to that sample and hold because it's the value of my phasor which I'm using. And each time I trigger my a new kick, I want to sample the value of my phasor because that's the value from which I'm going to start. So I'm going to trigger a click because sample and hold is driven by a click by default, or maybe it can be triggered by a bang. Let's have a look. No, that's really a signal that it's expecting. That was what I thought. So we are going to send a click. So the click is that 1-0 instant switch. This click will be driven by the incoming message. So if I just press get, so that's a signal that we drive after. So let's display it using the number tilde, and each time I press play, I will get the value which has been sampled. So each time it's going to be different. So if it's 0, it means that I've just sent my kick at a moment in which my phasor was at 0, but it can be any value. And what I want to do is each time I do that sampling, I want to make sure that my phasor, instead of sending that value, will send 0. So how do we do that? Simple. I will remove that phase shift from my phasor. This way, the signal which I get here will be my phasor, but with the difference of the initial phase. And so this signal is restarting each time I press play. So let's try to use that as my phase. I'm going to remove this connection. So we actually are creating a value. And let's check if we have done it properly. I'm going to press play. Not yet. So let's check if we have actually done it right. Let's clean up a bit. We have too many windows open. So it doesn't seem to be working so far. So I'm sampling my value. Let's press play to monitor live. I'm sending the click at the right moment. You see that the frequency is changing. let's monitor what's going out of this. It's going to be a bit difficult to check if it's working, but it's, yeah. There's of course something wrong because my phasor should always output a value between 1 and 0, which is of course not good. So I'm gonna make sure that I have it properly. So let's do this trick. So I'm gonna add 1 to my phasor. So I just will add a full phase to my phasor. Do this difference. So now it sounds worse, but then I can use the modulo. So modulo the signal, and I'm gonna make sure that it gets back to between 0 and 1. Let's check it out. I'm not sure that it's getting better. My click is banging properly. Let's check that. Yeah. Yes, this one I will do anytime. It's between 0 and 1, so that's okay. Let's check if I'm sampling properly. So I'm gonna do a sample and hold of my difference to make sure it should be 0 when I'm starting. So just copying all this. So yeah. So we're actually okay. So we're starting always with a phase which is 0 or 1. It corresponds to the same value. But still my output doesn't seem to be in sync, which is a bit annoying. Yeah, so maybe I'm not precise enough with this kick triggering. Shouldn't change here. Actually the same click should be used at each point, so I will use the click here because it has to be triggered by the same source. So far it doesn't seem to be the exact thing that we're looking to, so we need to figure out another way and to correct that. So I'm not really happy with what is triggered there. It's not bad, but it's far from being perfect. One of the issues in Max is that to achieve a sample accurate behavior usually means using only signal-driven information. So all these cables which conduct signal information, audio rate signal information. And as you see here, we have a mix and match between stuff which is generated by messages or bangs, which are definitely not audio rate, though they can be synced, and some elements which are audio rate. So it's a bit, it's quite some work, but we can try to switch most elements that we have here in signal behavior. The most difficult one is the functions. Yeah. So if I open again the function documentation, you see that there is absolutely no way to drive it using signals. So it has to be triggered by a message or by a floating point, but by anything which is something which is actually not signal driven. So what I've done, it's a trick that I've used on my enveloper device, though I think I found a more elegant way now, is to somehow sample the output values of the function and store that into a buffer or a waveform, so that it's actually a signal-based stuff. To do so is we need to have several stuff happening. So we need to monitor each time this function is changed. So this function is changed, and we need at each time it's changed to fill a buffer. So a buffer like a wave file, which will contain the exact values of that envelope, that function, for all my signals. So to do that as clean as possible, so we're gonna need a few objects. The first one is, of course, the buffer object, which is, as the name stated, meant to store audio information, so audio rate information. So we're gonna name this buffer pitch buffer, for example. And buffers is supposed to have a size. However, now I can't tell the size at the start, so what I instead know is that I'm gonna receive the size from here. So this is my inlet when the length of my kick is. So I can use that message, and if you see the types of messages it's waiting for, so we have set size here. And I think attributes, we have size as well. I'm not sure. I think that set size actually resizes the object without dumping again, without changing the value. So it's like resampling. Let's check it out. So if I'm using set size, not that clear, because there is as well the size message. Yeah, both they seem redundant, so I don't know. So let's try and use size. So each time I'm getting the size from here. I'm gonna use it and send it to my buffer. So that's gonna be size $1, and I'm gonna receive milliseconds, and it's the actual thing that it's waiting for. So this is our buffer. It's only the place where we'll store the information. Next, we're gonna figure out a way to dump, because that's really it, to dump that function each time it is changed. As you see here, this latest outlet actually produces a bang when the function is changed with the mouse. So we're gonna use that to trigger the dump. However, if I wanted to do this kind of thing, I would need to use that to send requests backwards to the inlay, and again gathering them from here, which is a bit heavy, and if I'm playing at the same time, and so I'm receiving bangs from here, then I'm gonna output a lot of values from anywhere, so it's a bit I don't think it's gonna be stable. So we're gonna use a feature of the function which allows to copy the content of a function into another one. So we're gonna use a second function. This one will not be visible, so I remove it for the presentation. And it's gonna have to do several things. So firstly, we need to sync this function with this one in terms of range and domain. So it's going to receive the same messages, so it's going to be resized instantly. And next, we want to copy the content of this function each time this one is changed. And by the way, we're going to dump this function, because this one will not be triggered by the incoming MIDI messages that we get here. So it's not going to be jeopardized by these incoming MIDI messages. So let's figure out what we have to do when we receive a bang. So I'm gonna put an actual bang here just to monitor that we are sending bangs. So if you just touch here something, you see that a bang is outputted each time I changed the value or a point in my function. But I want to do several things here. So I'm gonna trigger some elements. So for now, we don't know yet what we have to do. But what we are sure of is that we're gonna record the output of this function into my pitch buffer. And to do so, we're gonna need the record tilde object. It needs one argument, which is the name of the buffer. So record into pitch buffer. It's going to record values that will come from somewhere. But what we will do is each time we get a bang, we need to use the copy message. So the copy message will actually copy all the current function points to the clipboard, and we have the paste message, which allows to paste anything which is inside the clipboard to a function. So we're gonna need to remember that we are going backwards. So the first thing that's gonna be triggered is to the right. So we need to copy, then paste, and then we're gonna record. And to do so, we're gonna activate the recorder. And so to activate recording, we need to send 1 to our pitch buffer and output the bang to this function so that it's gonna do its thing. So if I connect correctly, so copy will be sent to the initial function, paste to the new function, 1 will be sent to the recorder, and now the bang will be sent again to this function. Now we need to get the actual information from here. If you have a look how we are using the output of the function, it's driving a curve. So it's a curve which is going out of the second outlet that we want to use. So curve. And the signal, because that's actually what we're getting, the signal which goes out of curves will go into our recorder, and the data will be sent to that buffer. So firstly, let's check that when I change the function, this one follows. Yeah, as you can see, as I'm moving one function, the other follows instantly. But I don't know yet if my buffer is actually working. So I'm going to need to display the content of a buffer. So how do we do that? We have that object, which is called waveform, which allows to display the content of a buffer. So I'm going to copy this directly from the documentation, because in the documentation you can unlock, and so you can copy the objects. And I'm going to ask this waveform to display the content of the pitch buffer. So I will trigger manually. So if I command or control click on my message, I actually send the right values. And there is one thing that I need to do, because here I'm outputting pitch information. So between 0 and 127, a waveform by default is using between -1 and 1. So I'm gonna zoom out. Sorry. So attributes, we got the vertical zoom here, V-zoom. So if I click there, I can adjust that value, and I'm gonna put it to 127. So I'm sure that I will be able to display the content of my buffer. But still, it seems to be empty, doesn't it? Yeah. So let's see. Yeah. Let's see that the curve is actually sending the proper value. So we get these values here. So curves should be sending properly. Let's monitor this, the output of curve using a scope, like so. Yeah. It seems to do something. So let's check that between 0 and 127. So making sure, my buffer size, is 0 for now. I need to make sure that my duration is actually sent to my buffer. So now my buffer has an actual size. And if I switch here to the display of my waveform to milliseconds, you see that the size here is following my slider there. So each time I change the length of my kick, we see that waveform is following, so it's good. And now if I click there, you see that my buffer is being filled by the shape that we are seeing there. So we now have a buffer which contains the exact copy of my function, but on a signal-driven value. That's the first step. The next step, yeah, we can clean up a bit. Let's remove this. We're not going to need it. We can do something like that. It's a bit cleaner. This bang is triggered there, and we can actually put that a bit higher. So we get our two functions next to each other. This is not very useful, but I'll keep it for the time being. Let's save. And now, instead of on my pitch, instead of using that function directly, I'm going to read out from the pitch buffer. So somehow this input is not needed anymore. So, and this curve as well. So here we have to replace it by some way of taking the contents of this waveform. So how do we do that? We're going to use the line instead of the curve, and the line will go from 0 to let's check the documentation of line to see list and target value and total amount of time. But I can, as you can see, I can send line is actually allowing us to go from one value to another in a linear way, and we can do a list of different destinations. So for example, here I will go to 0 in 1000 in 1 second, and then to 1 in 1000 in 1 second. So this line, which has no parameter, will be generated each time a note is inputted, and it would actually go from 0 to 1, so 0 instantly, and from 0 to 1 in a specific value. So that's going to be $1, which I'm not sure, which we don't know yet, and this will be triggered by my incoming message. So what's the actual value here? It's the length of a kick, because we want to go from the minimum of a buffer to the maximum of a buffer in 536 milliseconds. So this is the value that we are filling here. Okay, so again, let's have a look on the scope. It's usually, the scope is really interesting. Okay. And my scope should go, so that line is it's gonna go to from 0. I made a mistake, sorry. Because if I do that like it is, it's gonna replace the full content, so it's not what I want. I'm gonna go from to 0 in instantly, and then to 1. But this value here will be used. Hold on a second. Think about the cleanest way to do that. My value should be packed somehow. So let's see if I can do something like that. 0, 0, 1, and a floating point. Not sure. No. Pack is not the right object here. Yes, so I'm gonna use the prepend instead. So whatever length my kick should be will be sent here, and we're gonna prepend to it the 3 values there. So if I change that, you see that my message here is gonna contain always 0, 0, 1 and my length. And that message will be sent out to line only when we trigger a kick. Let's have a look. As you see, we got to 0, and in 573 milliseconds, we're going back to 1. But again, this is not the exact thing that we want. What we want is the content of my buffer instead. And the content of my buffer can be addressed using the index tilde. So that's, again, I need to put the name of my buffer. So we are addressing pitch buffer. And index read from a buffer with no interpolation. So we're going to have the precise value, and it is expecting a value which corresponds to the place in which we want to get the value. So my line here will be connected to the index, and if we monitor the output of index, let's see what it does. But before that, we need to make sure that we are mapped to our pitch values, to our pitch values, so between 0 and 127 on my waveform display. And if I click here, I should get this shape. Oh no. So my buffer is okay. Let's open index information. So it's waiting index between signal sample index. No, that's message. Set sample index, so it should be okay because I'm gonna read our sample index. So that's not gonna be it's not gonna be milliseconds. It has to be in samples. So that's why it's not working now. Let's make a bit of room. So I need to convert my use the same kind of trick here. So I'm going to translate my length in from milliseconds to samples. Okay. And no, yeah, it's not here. Sorry again. So firstly I translate, then I prepend. Okay, and now I remove this and I put it here. And now, yeah, I'm back to something. Okay. Checking it again if my line is working fine now. Yeah, but it's invisible. 0 to 1. Oh, that's very slow. Because this one is waiting for samples in terms of duration. All right then. So it's a bit trickier because I need my destination here. I'm not going to 1. I need to go to my length in samples. Okay, so I'm starting from 0, that's fine. But then I'm starting from 0 and I'm going to I'm going here. Starting from 0, sorry. Yeah. But then I'm going up to the number of samples. So I'm gonna append. I'm gonna collate actually. I'm gonna pack. So now I'm gonna use this value as well. Pack the 2 of these. Join. That's actually joining lines. So join is ZL is that's very complex one, so I'm not going to go too far in this one, but it's combining two lists into another only one. So ZL.join, and the second list will only be this thing. And so if I receive here, there, this thing there, let's check what it does. Yeah, so what I have now is starting from 0, 0, I'm going in for 38 milliseconds from 0, the sample number 0, to the sample 19,000, which is the end of my pitch buffer. Should be alright now. Yeah, something there. That's the opposite actually, so this one should go. Yeah. So we need to have this one going there, because it's going to happen first, and this one going there. Yeah. Oh, that's a big one. This doesn't seem right, does it? Oh, that's a, yeah, there's a comma, okay. And I've lost my pitch buffer, which is bad news. Yeah, because when I change the domain, I don't actually retrigger the calculation of my waveform. So this is something I have to add here. So whenever I change the range or the domain, so it's the length or the MIDI, I want to update this one, this buffer as well. So how can I do that? I only need to trigger a bank, which will trigger this thing each time I receive anything from one of these three inlets that we have here. So now, So now if I put this aside, if I change, just to show you exactly what I'm doing. So if I change the length of this, you see that my waveform is getting redrawn, which is exactly what I want. So whatever I do, if I change this as well, because we are changing the minimum and maximum MIDI notes, so that's what we want. Now I should get something better from my index. Yeah, you see that my index is following my waveform, my buffer. So there are a few things that I actually don't need. So now the index of my pitch buffer, instead of this curve, will control my the frequency of my envelope of my kick. Need to break that. Better. Let's just check what is happening on a phase standpoint, if it's any better or if it's just the same. It doesn't seem to be that better for now. change in phases, not, I know it's not big, but it's still happening. So I'm gonna make a break now and think about the exact situation. I'm gonna clean up a bit, of course, because now it's totally a mess. This is me brainstorming on and trying to solve issues and trying to find the best way to do things. And sometimes it takes a bit of time, and the devil's in details, as we know. So we started from something which looked very simple, but yet it has to be. We have a lot of details to follow. If I look here, we see that we are slowly shifting every like 8 kicks. So we need to figure out where this slight phase change is coming from. That is going to be for next session. Alright then, so that was not the most simple session today. As you have seen, we're still struggling a bit to deal with this phase retriggering. We've made part of the way, I think, by switching the function from using a message to drive the pitch to a buffer based, so audio rate driven pitch envelope. And but we still have some objects which seem to be working through messages, and next session will probably be around switching everything starting from the MIDI to audio driven signals to make sure that anything which is happening inside the device is working audio rate and can be as precise as it has to be if we want to have an exact retriggering of our kick each time we press a note. In the meantime, if you like my videos, please hit like and subscribe on this one. And if you want to support me further, please join my Patreon, and this way you'll get all these device versions, and as well you're gonna get access to my free buys, which I post around once per month, and some discounts that you can have on the rest of my software on my Gumroad shop. So again, thank you for your time, and see you next week.